Well, hello everyone. I'm back with a another video tied to my ITS2300 data networking class. This time we're talking about ICMP and the chapter relating to it in our textbook. So let's jump right in and take a look at our TCP Illustrated book, the updated Stevens Fall version. ICMP is described in Chapter 8. And this chapter it's harder to delineate the readings for you because a lot of times you really need to read the beginning of a chapter, but then they get into a lot of details. So I'll try to point that on a couple of places, but it isn't. I'm not always going to be able to. So in most cases, you want to focus on the intro text, so the first 1, 2, 3 paragraphs of a section, and then it gets into, Wireshark captures, console output listings, those kinds of things. You can pretty much assume that you've read everything that we want to cover and skip the rest of the detail. So as usual, we'll want to read the introduction. Just a quick reminder of how ICMP travels in IPv4 and IPv6. It is its own protocol, so it's carried kind of like a transport protocol. And then you want to definitely look at the ICMP4 and 6 messages. And here's I'm going to jump over in. So again, I can't really scroll through the chapter because of copyright reasons, but I can obviously pull some excerpts. So in these two sections here, the ICMP4 and IPv6 messages, ICMPv6 messages. There we go. That's the one I wanted. And where's my zoom here? There we go. So I pulled two of the tables that you find in that section. So the point here is you want to read through these tables to figure out what's there, but you don't have to memorize them. There's absolutely no reason for you to know which type is which, but you need to know that something like an echo request or an echo reply is something that is an ICMP message, and it is defined by a type number. Right, so for example, ICMP4 type 0 is echo reply, and so on. But you definitely do not need to memorize these. And the other thing you need to look at, again, not memorize, is, and by the way, this one sort of indicates which ones of these are informational as opposed to error messages, which is useful to know. Basically, for the most part, this really matters most for type 3, which is destination unreachable. There are lots and lots of reasons why destinations can be unreachable, and so those are distinguished by the code field. And so it could be network is not reachable, a port is not reachable. We talked in class about the packet too big issue, and the resulting error message because the packet has to be discarded if it is not allowed to be fragmented. All right, so this table, again, nothing to memorize here, but if somebody refers to, or somebody mentions a destination host unknown error message, you need to sort of have a sense that that's a particular ICMP type and code number, even though you might not know what the numbers are. And frankly, if you're using Wireshark, it's going to translate all these because these tables are built in. So it's going to translate all these codes into human readable form. All right. So you can safely skip the processing of ICMP messages. Lots of basically computer science style detail in there that we can skip for this class. Read the section on ICMP error messages. Again, there are definitely sections in there that go well beyond what we want. So as I said, if it gets into Wireshark captures, if it gets into, I think there's a telnet example in there or something like that. You can safely skip that. What you want are always the introduction to sort of describe, how each error, what's happening in each of these error instances. There's a really good section. You can skip the extended ICMP multi-part messages. That gets us too far into the details we don't need. There's a pretty good chapter here on what we discussed in class. The packet too large issue. And so that's ICMP v4. That's the type 3 with the correct subcode, and it has its own type in ICMP v6. So 832 is kind of useful to read. 833 talks about the redirects. We talked about that, where a router, where a host sends a packet to the wrong router. The router knows that there's a better route, so it forwards the packet, but also sends this ICMP redirect. There's the ICMP time exceeded. That's the time to live parameter. So if the time to live is exceeded, the packet is discarded, and ICMP error message is sent. Of course, that's what we use in traceroute, and there's a nice explanation of traceroute. Again, you've done traceroute in class. We're going to take a look at traceroute packets in one of the upcoming labs. So no need to dig through their listings of Wireshark output and that sort of thing. You can pretty much skip the parameter problem. Not that it's unimportant, it's just not as common. Then it talks about echo replies, so the ping utility. You definitely want to read that, and the introductory query informational part. Then we can pretty much skip forward. You should read the section on neighbor discovery in IPv6. That's the that is the ARP replacement for IPv6. Read kind of the first paragraph or so in the router solicitation, router advertisement section. You get a sense of what that's about. And again, that's the neighbor discovery replaces ARP. The router solicitation advertisement replaces a part of DHCP. So those are, so you need to know that. And then the remainder of the chapter, other than the summary, is you can skip. It's that gets a little bit more detail than we need. Take a look at the section about attacks involving ICMP. I talked about that in class. Because ICMP, especially things like the echo and echo reply packets, are allowed to carry an arbitrary amount of information. Not an arbitrary amount, a fixed amount, but of arbitrary content. So it is possible to use a ping packet to carry information that a firewall might not recognize as being sensitive. The other ICMP packets, and you'll see that in the reading, all carry a portion of the offending packet, right? So if a packet had to be discarded and triggers an ICMP error message, as much of the packet header as will fit into the ICMP packet gets copied in, so that for diagnostic purposes you can sort of see what caused the problem. Of course, a malicious program could replace what is supposed to be a copy of a packet, again, with surreptitious information we're trying to get past security devices. So ICMP is subject to various security issues, and because it is an operational protocol where you can redirect traffic with an ICMP message. You can advertise that you are a router serving the network with an ICMP message. You can indicate that a particular network or host is unreachable with an ICMP message. So there are lots of different ways in which attackers could abuse ICMP. So take a look at that section, and we'll give you a little bit of a sense of what some of those issues are. I'm going to do just a really brief summary here, and bring my Jamboard up. Let me do that now while I'm chatting here. There you go. Oh, that's right. I can always. There we go. There's an empty one. All right. Let me plug my tablet in real quick. All right. So we've talked about ICMP in the in class for a few days. But if you either missed that or you want a refresher, I'm not going to repeat all of it, obviously. But the first thing to realize is that ICMP messages sort of come in multiple flavors, and I think the chapter points that out, right? So there are the packets that are supposed to provide information in IPv4. That's the echo and echo reply, and then you can add router advertisement and neighbor discovery and those sorts of things. Although I can kind of think of those more as part of configuration, right? So this would be ping, and when I say that, understand that's echo echo reply. Configuration would be to my mind is, and the book might call these informational, but configuration type ICMP messages to me are things like the redirects, router advertisements, neighbor discovery. Those kinds of things are used to sort of fix or augment network configuration. And then the biggest block, of course, are error messages. And so on the info side, we know we have the reachability. Again, with the ping utility. Again, always subject to firewalls blocking ping. Error messages are, obviously the most common, the ones we care about. If something is unreachable, there's a problem somewhere, right? Either a route is missing, a host that is supposed to exist is off, a program like a web server that's supposed to run on a server is not running. That will generate a port unreachable. The host not being available would be a host unreachable. Network unreachable means you have a routing problem. So those are probably the most important error messages. And then you have the packet too big, which in IPv4 is an unreachable packet, needs to be fragmented but cannot be. And in IPv6, it's a separate message. We talked a little bit about in class about the fact that I can use those messages at the operating system level, change the size of IP packets I send out. Applications generally don't do this themselves, but modern operating systems will use these ICMP messages to actually dynamically make adjustments for particular destinations. Make adjustments of how big an IP packet they send out and attempt to overcome these errors. And then, of course, we have the TTL, the time to live exceeded, which has two uses. One of them, obviously, is if I have a routing loop somewhere, I'll get an error message that warns me that my routing is messed up in some way, and it's causing packets to run around an excessive amount of time and maybe forever. Which, of course, is what the TTL was designed to prevent. And so getting that message, again, alerts you to a routing issue. And then, of course, I can also use it in the traceroute utility to actually sort of get a sense of, what's one hop away from me, what's 2 hops away from me, what's 3 hops away from me, and so on. So it's useful when you read through, especially this chapter is fairly lengthy. It's useful to sort of categorize things and think of, even though ICMP is kind of one protocol, think of it really serving 3 completely different functions, and it's all been kind of squeezed into this one protocol to accomplish, a number of different things once you had that kind of utility protocol available. All right. Well, as always, I hope this was useful. and I will see you in the next video.